Today's lesson, comparison between water, HCl and ammonia in the light of Bronsted-Lowry acid-base concept. In this lesson, we are going to learn Bronsted-Lowry acids and bases and amphoterism, the acidic and basic nature of water, acidity of water and HCl. Ammonia is a kind of basic compound, and finally water is a kind of amphoteric compound. So let's begin. The very first point is Bronsted-Lowry acids and bases and amphoterism. Firstly, let's see which compounds are Bronsted acids and which are Bronsted bases. Bronsted acids are hydrochloric acid, nitric acid, sulfuric acid, water, etc. And Bronsted bases are ammonia, hydroxide ion, water, etc. So these compounds are Bronsted acids and these are Bronsted bases. According to Bronsted-Lowry definition, the compounds, hydrogen containing compounds that can produce protons are called Bronsted acids, and the compounds that can accept the protons produced from Bronsted acids are called Bronsted bases. One thing is observed here that water is a kind of Bronsted acid. At the same time, water is a kind of Bronsted base. This matter is known as amphoterism, and water is a kind of amphoteric substance. That means the substance that can act as acid and base. According to Bronsted-Lowry acid-base theory, these compounds are called amphoteric compounds, and this phenomenon is known as amphoterism. Now let's see the acidic and basic character of water. That means amphoterism of water. Acidic and basic nature of water. In this point, we will see how water shows acidic and basic nature according to Bronsted-Lowry acid-base concept. This is a structure formula of water. Here, the electronegativity of oxygen is 3.5 and hydrogen is 2.1. So in water, the electronegativity difference between hydrogen and oxygen is quite high, and for this reason this bond, hydrogen oxygen bond, is polarized, and at one stage this hydrogen oxygen bond shows heterolytic fashion, and from this hydrogen is released as proton. So in this way, water molecule acts as Bronsted-Lowry acid in basic medium. So water here acts as acid. Now let's see the basic nature of water. This is water. Oxygen contains two lone pairs of electrons. When this water is in acidic medium, that means the medium which is full of protons, then this water, that means oxygen atom with its lone pair of electrons, binds hydrogen ion or proton with itself with the help of lone pair of electrons. That means water here accepts proton in acidic medium, and according to Bronsted-Lowry concept, the compounds that can accept protons are called Bronsted-Lowry bases. Here water accepted proton, so water acts here a base. So water is a compound that can show acidic and basic character in basic and acidic medium. This is the amphoterism of water. That means water is a kind of amphoteric substance. At the last of the lesson, we will show the amphoteric character of water with reactions. Now the point is acidity of water and HCl. We all know that HCl is a kind of stronger acid than water. Here we will know the reason behind this. There are two reasons. One is Ka value, acid dissociation constant. Ka value for HCl is 1.3 into 10 to the power 6, but Ka value of water is 1.0 into 10 to the power minus 14. We know that the larger the value of Ka of an acid, the acid will be more stronger. So from the Ka value we can say that HCl is a kind of stronger acid than water. This is number one. Number two is formation of proton. Which compound can form proton easily? This is the point. Here, this is hydrochloric acid. The size of chlorine is bigger compared to size of oxygen. The size of chlorine is 99 picometer radius, and the atomic radius of oxygen is 66 picometer. So chlorine is bigger in size compared to oxygen. As a result, the bond between hydrogen and chlorine becomes longer compared to the bond between hydrogen and oxygen. As a result, this bond breaks easily because of the longer bond compared to hydrogen-oxygen bond. And the bond distance is here 1.275 angstrom, and here the bond distance is 0.958 angstrom. Since this is the longer bond, it breaks easily and proton and chloride ion are formed. Since this bond breaks easily, it becomes stable. But in this case, the bond is shorter compared to hydrogen-chlorine bond. As a result, this bond breaks but not easily like hydrogen-chlorine bond. And in this case, proton and hydroxide ion are formed. Since this bond doesn't break easily, that is why this is not stable. So this is stable compared to hydroxide ion. Considering these matters, that means size of chlorine and oxygen and bond distance, HCl produces protons easily compared to water. That is why HCl is a stronger acid than water. So the point is here, water acts as acid in basic medium and water acts as base in acidic medium. So when water is added to HCl, it will act as base and it will act as acid because hydrochloric acid is a stronger acid than water. This is the point here. Now the point is, ammonia is a kind of basic compound according to Bronsted-Lowry acid-base concept. Let's see how ammonia is a kind of basic compound. This is a structure formula of ammonia, where nitrogen contains one pair of electrons. When ammonia is added to acidic medium, then this nitrogen, with the help of lone pair of electrons, binds oxygen with itself, and then ammonium ion is formed. So ammonia can receive proton. That is why ammonia is a kind of basic compound. But here there are 3 hydrogen atoms, so there is a chance to be acid. Here the electronegativity of nitrogen is 3.1, hydrogen is 2.1. So difference is quite satisfactory. So the electronegativity difference is quite satisfactory. Nevertheless, from the ammonia, no proton is formed because when these electrons shift towards nitrogen, then around nitrogen concentration of electrons is increased. That is why these covalently bonded electrons cannot shift towards nitrogen properly, and for this reason from ammonia no proton is formed. That is why ammonia is a kind of basic compound only, not acidic compound. Nevertheless, when a proper environment is created with ammonia, then one proton is released and this ion is formed. So ammonia can act here as acid, but this is extremely rare. So we can say that simply ammonia is a kind of basic compound according to Bronsted-Lowry concept. That means ammonia can accept proton with the help of lone pair of electrons. Let's see the next point. Now the point is, water is a kind of amphoteric compound according to Bronsted-Lowry acid-base concept. That means water can accept proton and can donate proton. Let's see through chemical reactions. When water is added to ammonia, then we already learned that ammonia is a kind of basic compound, so it will receive proton produced from water. That means water is a kind of acidic compound here. That means water can act as acid in this reaction, so it will donate proton and ammonia will accept that proton. After donating proton, it becomes hydroxide ion and ammonia becomes ammonium ion. So in this reaction, water donates proton. So here water is acid. If we see another reaction, that is when water is added to HCl, we know that HCl is a kind of stronger acid than water. So in this case, in presence of a stronger acid, water cannot act as acid, rather it will act as base. That means this HCl will donate proton and water will accept that proton. In presence of a stronger acid, water acts as Bronsted-Lowry base, that means proton receiver. Now let's write the products. After receiving proton, water becomes hydronium ion and HCl becomes chloride ion after donating proton. So in this reaction, water acts as base. So from these two reactions, we can say that water is a kind of amphoteric compound, because water in this reaction acts as acid and in the second reaction acts as base. So according to the definition, that means the compounds that can receive proton and donate proton according to Bronsted-Lowry concept, those compounds are acid and base respectively. Since water can donate and can accept proton, that means can act as acid and base, water is a kind of amphoteric compound. No more today. Thank you very much.